Fossil fuels, petroleum, coal, natural gas, all release huge amounts of energy during combustion. We see here 1 mole of methane reacts with 2 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water, and the energy, 890 kilojoules. If we think about it though, fossil fuels are another form of solar energy, because millions of years ago, ferns and plants absorb sunlight in the previously discussed endothermic reaction of photosynthesis. They use that energy to fix carbon dioxide into organic molecules. And so the energy that we're actually releasing when we burn methane came from the sun. And so it's really another manifestation of solar power. It's just that energy has been trapped in those molecules in the earth for millions of years, and it's been sequestered down there, and now we're tapping into it and releasing it. But fossil fuels is another form of solar energy. Those plants only grew 65 million years ago because the sun was shining. Combustion does not occur at normal temperatures without a spark. You need something to get the reaction started. That's because almost all chemical reactions have an activation energy. You need to put in a little bit of energy to get the energy started. And this is true for endothermic reactions. How do I know this is an endothermic reaction? Because the products are at a higher energy level than the reactants. Therefore, they absorbed energy throughout the whole reaction. But notice, I have this hump here. That's my activation energy. In an exothermic reaction, how do I know that it's exothermic? It released energy. Energy is a product. So as I release energy, my products are lower energy than my reactants. But notice I still have this energy hump. So in both endothermic, like here, and exothermic, like here, you have an activation energy. You have to supply enough energy to deform and contort the molecular bonds enough to get the reaction started. And so with the sole exception of 2 free radicals meeting up, every other chemical reaction has an activation energy. If you want a bonfire with your friends, you can make a huge pile of wood, but you can't just stare at it to start the fire. You have to actually use a match or use some sort of energy source or rub 2 sticks together until friction causes a fire, but you have to input enough energy to get the reaction started. That is activation energy. Fossil fuels produce carbon dioxide during combustion. And right now, 50 billion tons of carbon dioxide are released into the atmosphere annually. And scientists measure carbon dioxide levels in parts per million in the atmosphere. And the average global temperature has risen by 0.74 degrees Celsius over the past century. Why? Because carbon dioxide is a greenhouse gas. We talked about greenhouses before, but basically, a greenhouse works because the clear glass allows visible light to pierce through the glass, but then when that photon of light bounces off of something and becomes infrared, it gets trapped in the glass and it can't escape. And greenhouse gases work the same way. They allow the visible light in because they're clear, but then when that photon bounces off of something and becomes heat energy, it gets trapped. Methane is a much more potent greenhouse gas than carbon dioxide. And that's why sometimes at a landfill, you'll find a torch that's burning, just because it's better to release carbon dioxide than methane into the atmosphere. Because methane is about 20 times worse of a greenhouse gas than carbon dioxide. So methane is a much, much worse greenhouse gas than carbon dioxide. So it's better to burn the methane and release carbon dioxide. Then again, that is how greenhouse gases warm the atmosphere. The energy is allowed in, but then it bounces, it changes to infrared, and it's trapped inside, and the Earth is slowly warming up. That being said, it's important to remember that when we burn fossil fuels, we're putting the carbon dioxide back to where it was a long time ago. Because if we go back 70 million years ago, the carbon dioxide was already in the atmosphere. And then photosynthesis occurred. All those ancient ferns sucked the carbon dioxide out of the air and made organic molecules, which later got trapped, buried, and fossilized into the fossil fuels. And so as we burn them, they're going back to where they were. So it's more appropriate to view fossil fuels as sequestered carbon. It was once in the atmosphere, and then it got trapped underground for a long time, and now we're releasing it back into the atmosphere. And so it is changing the Earth, but it's important to remember that it was once in the atmosphere. That being said, when all the carbon dioxide was in the atmosphere, Earth was a lot warmer. And so 70 million years ago, the whole planet was tropical. If you dig down in the northern parts of Canada, you find tropical fern fossils because the whole world was once tropical because it was a lot warmer back in those days. And so as we burn these fossil fuels and release carbon dioxide, the Earth is warming up slowly, which is what you'd expect as you put the carbon dioxide back to where it was 70 million years ago. When we worry about global warming, it's not so much that it's going to ruin the Earth, because the Earth used to have no ice, and the Earth used to have all the carbon dioxide in the atmosphere. That's just putting the Earth back to a state that it was a long time ago. The bigger problem is things are less mobile now. If your area gets flooded, you can't just pack up your village and move 10 miles and claim new areas. All land has been claimed, and now we have invisible borders that you can't cross this line unless you have the correct paperwork and the right immigration paperwork. And so the bigger worry is that as all the ice melts and as there's flooding and as things go underwater, it affects areas unevenly. So if you look at National Geographic made a great set of maps showing what the Earth would look like if all the ice melted. And some areas like Florida would be completely underwater. And then some areas, like this class is based out of Iowa. Iowa would still be over 800 miles away from the ocean. No one would even notice that it happened here. And so global warming affects places unevenly. Flooding will affect places unevenly. But humanity has built massive great cities right by the ocean, and so if the seas rise and those get flooded, it will impact people, and no one's really sure how. Maybe everyone will treat it like Venice, where people just use boats to get around and carry on. No one knows. But that is the worry with global warming, is that the ice sheets of the Earth are melting and the sea is slowly rising, which threatens coastal communities. And that is the end of Chapter 8.